In 10.4, we are going to start talking about intercepts. And this concept is something that you covered in Math 1 last year. So it shouldn't be too hard for you. The only big difference is that we're going to be talking about quadratics. And so this example that I have drawn for you over here shows you what it would look like with a line, this blue line. But you need to start imagining what this would look like if it was a parabola, either opening up or a parabola that would open downward. That's how come there might be 0, 1, or 2 intercepts. So let's just remind you what the intercepts are, how to write them, what it looks like, and then hopefully the worksheet will start making sense. First and foremost, X-intercepts always have a 0 in the Y coordinate. Doesn't matter where this crosses the X-axis. This is your X-axis. If you look at it, there's going to be a 0 for the Y because you're going 0 units up or down. You don't know how many units you might be going to the right. It might be a positive X value, like a positive 5, 0. Or if the X-intercept was over here, it might be a negative 5 or a negative 2. The left coordinate is your X coordinate. We don't know what's going to be in that spot, but we do know that the Y coordinate is a 0 for the X-intercept. This is important because if you ever want to find the X-intercept, all you have to do is plug in 0 in for your Y value. If you ever want to find the Y-intercept, all you ever have to do is plug in a 0 in for your X value and figure out what is your Y. Knowing which one is which will help you figure out what you're finding. The reason why I included this graph was to try to help you visualize what it is you are finding. If you're finding where it crosses the Y-axis, or if you're trying to find where it crosses the X-axis, if you look at this and you were to think about numbers, and you were to think about whatever the numbers would be, you're going 0 units to the left and right for your X, but you're going up however many units, Y units. It could be a 4, it could be a 3, or whatever it may be. This lets you know what it is you're finding. Just like any other point, like X, Y, left, then right, X-axis, then Y-axis when we find those points. When we find our intercept, we're going to write them as ordered pairs. That means parenthesis X, comma, Y. Whatever our X value is, whatever our Y value is, we're going to write our answers in parentheses. These are locations, places where they cross the axes. Sometimes there's 0, 1, or 2 intercepts with quadratics. Think about it. If I had a quadratic that was going through like this, it might have 2 X-intercepts. But if I shift the graph up a little bit, it might only touch the X-axis in one spot. This has 1 intercept. Or sometimes the ones that students always get confused on, Mr. Paramo, doesn't touch the X-axis? I know. There are 0 X-intercepts on the last graph that I have exampled here for you, or that I gave you as an example. So don't freak out. If it is above the X-axis, there is the possibility that it has 0 X-intercepts. That is a possibility. Keep that in mind. To find the intercepts, you can either look at the graph and see where they cross the X or Y axis, or you can plug in a 0 for one variable and solve for the other. I'm going to use both techniques when I get to the examples. Let's actually get to the examples. Here's my plan. You have the worksheet in front of you. I'm going to do problems 2, 5, 8, 15, and 24. Let's look at number 2 together. It says, based on the graphs, name the X and Y intercepts as ordered pairs. So we have to use those parentheses. If a graph does not intersect an axis, write none. So they're letting you know some of these will not have an X or a Y intercepts. Don't freak out if that happens. So we look at the graph for number 2. The X-intercept. If you don't see it, a lot of times I'm going to recommend put the X and put the Y. X is your horizontal axis. Put the Y, the vertical axis, if you can't see it. It was there. It's a little blurry. It's there. It's a little blurry. And if you also get stuck, write down the numbers. If this is 1, 2, 3, then write the other direction, -1, -2, -3. It might be helpful for you to write 1, 2, 3, 4, 5, 6. It might be helpful to write the numbers out. So the first thing it asks me to find, what's the x-intercept? Where does it cross the x-axis? X-axis, where does the line intercept or cross the x-axis? And it's right here. Don't just say -3. It's an ordered pair. For x-intercepts, our x-coordinate is -3 and our y-coordinate is 0. To write the x-intercept, we write it as -3, 0 in parentheses. That's how you get full credit on your quiz or test. The y-intercept is going to be slightly different. It crosses the y-axis at this number. If you don't know, you're going how far left and right? You're going 0 units left and right, and you're going up 6, so it's 0, 6. The hardest part about intercepts is knowing where the 0 is. For x-intercepts, the 0 is for the y-coordinate. For y-intercepts, the 0 is on the x-coordinate, and that's the only part that's hard. If you get stuck, think about how we graph. We graph left and right for our x. We graph up and down for our y. We always do this in alphabetical order, x first, then y. I'm hoping that helps. They first give you a line on number 2. And then on number 5, they give you an equation in vertex form and they have a parabola now. And they still ask you the same questions. They say, what are the x-intercepts, what are the y-intercept? And sometimes, do you notice that there is a, there's an S. There's 2 of them. There's 2 places where it crosses the x-axis. So just as we did before, label x and y. That's going to help you. Write out the numbers. This is a 1, 2, 3, 4. You can keep going. -1 on that side. I'm going to put a 0 right there. That way I have my x-axis labeled. My y-axis, 0, 1, 2, 3, 4, 5, 6, 7. So I know where things cross. To find the x-intercepts, it crosses here on the x-axis and it crosses here. There are 2 answers. Each one you list separately. I usually will go least to greatest because that's what the higher level, everything is done in higher level of mathematics, smallest to largest. So this is an x-intercept. Is it going to be 0, -1 or -1, 0? If you know, say it out loud. If you said -1, 0, you are correct. You went left 1, you went up 0. That's your first coordinate. That's the left one. In between, I just say comma. There's a right one. The right one, it goes through 3. Put it in parentheses. If you know, is it 0, 3 or 3, 0, say it out loud. If you said 3, 0, you are correct. It's okay if you got it wrong, but like I said, that's the hardest part of this section, knowing where the 0 goes. You went 3 to the right, you went 0 up or down. That's your x-intercept. That's where it crossed the x-axis. Your y-axis, it goes through this number that intercepts right there at 6. Is it 0, 6 or 6, 0? If you know or think you know, go ahead and say it out loud.
0, 6.
I heard a lot more correct answers this time. 0, 6 is correct. It should not be very hard for you once you figure out what it is that I taught you. Now, number 8's tricky. I picked number 8 because this is something you have not seen since the very beginning of the year in Math 1. You covered this in Math 1. I want to say it was Unit 0 in Math 1. And so it's been a year and a half maybe, or maybe even more than that since you've seen this. This is called an exponential graph. It's when the variable's in the exponent. Now this says, what's your x-intercept? And you might look at like, hey, this is crossing, and you might think that it's crossing the x-axis, but it doesn't. It never crosses through the x-axis. It actually just gets closer and closer and closer and closer, but it never actually crosses. There is no x-intercept. The answer is none for the x-intercept. And I could prove it to you. Oh, Mr. Paramo, it looks like it might go through right here. Well, if you plugged in -5 in for x, whoa. Let's see if I can fix that. There we go. If I plugged in ooh, I did it again. How did that happen? Okay. Learning something new with this computer. If I plugged in -5, 2 to the -5 is the same thing as 1 over 2 to the 5th, which is 1 over 32, because 2 times 2 times 2 times 2 times 2 is 32. It just gets closer to the x-axis. It does not make a value that crosses or makes 0. And the bigger the number that you put here, the more 2's that are multiplying, the closer you're getting without ever touching. The last thing, the y-intercept. I forgot to mention xy. I could put numbers down here, but I am going to label the y-axis because it crosses right there. Touches the y-axis, the y-intercept. Is it 0, 1 or 1, 0? If you think you know, say it out loud. If you said 0, 1, I heard a lot of correct answers. I heard about 4 people get it right this time. Good job. There's 4 people who can get these questions right on the quiz and test. Good. I want more, though. I want more. Number 15 is my next example. We only have 2 more examples and we'll be done. It says, state whether each statement is sometimes true, always true, or never true. If it's sometimes, give an example of each. A linear function has an x-intercept. Now, if you don't remember what a linear function is, that's just basically saying a line. I'm going to change colors to blue, and then I'm going to pull up this line. If you have a line and it looks like this, is it going to have an x-intercept? Does it cross the x-axis? What if the linear function was like this? A horizontal line below. Is this ever going to touch that x-axis? Okay, so let's go back to, it's not letting me pick that. Well, anyways, a linear function has an x-intercept. It does sometimes. That's my answer. My answer is sometimes. Why is it sometimes? If it's sometimes, give an example of each. Sometimes it will. Here's an example. It will go through. And sometimes it won't. When it's a horizontal line, either above or below the x-axis, that's the sometimes. Give an example of each. This is when it does. This is when it doesn't. Last example. Without graphing, calculate the intercepts. So far, we've used the picture to figure out all the intercepts. But is there a way mathematically to figure it out? Sure. If you remember that the x-intercept is where there's an x comma 0, the 0 goes in for the y. All you have to do, if I'm trying to find the x-intercept, I can just plug in 0 in for y and figure out what x has to be to produce a y coordinate of 0. So the math behind this would be plugging a 0 in here and figuring out what does x have to be to get that y. Here's what you do. You add 8. 8 equals 2/3 x. Minus 8 plus 8 makes 0, goes away. Plus 8 there makes 8. And I want to get rid of the 2/3. 2/3 is multiplying the x. You can divide by 2/3. If you don't know how to divide by 2/3, when you divide by a fraction, you're just multiplying by its reciprocal. You can think of it as the opposite of 2 over 3 is multiplying by 3 over 2. It's the same thing. Dividing by 2/3 is the same as multiplying. So 2/3 divided by 2/3 goes in once. Dividing by 2/3 is the same as this. You can do top times the top, bottom times the bottom, and reduce. Or you can reduce right off the bat. 2 goes into 8 4 times. 3 times 4 is 12. When y is 0, x is 12, you write your answer as an ordered pair. X first, then y. 12, comma 0. Now if I wanted to find the y-intercept, the y-intercept is where the x is 0, and we got to figure out what y is. So I'm going to take this equation, I'm going to leave y alone this time, and then what I'm going to do is I'm going to plug in a 0 in for x and see what does y have to be in order for x to be 0. I replace the x with a 0. 2/3 times 0, that's an easy one, 0. 0 minus 8, oh, that's easy, negative 8. When x is 0, y equals negative 8. That is your y-intercept. Mathematically, we figured it out. So if you ever want to figure it out mathematically, plug in a 0 either for the x or y, and that will let you know. I did the x-intercept in red and the y-intercept in blue. I'm going to end your notes right there.